Hello dear colleagues, I would like to present our work, Algorithm and Software Tools for Ternary Pseudorandom Numbers, Generation and Randomness Assessment. My name is Sergiy DOROZHYNSKYI. In this paper, an approach to the generation and evaluation of ternary pseudorandom numbers quality was proposed. This approach makes it possible to generate and fundamentally evaluate the generally assessment statistical parameters and patterns. The result allows to evaluate the cryptographic security of treat pseudorandom numbers generators and their practical ability for various cryptographic applications. The modern quantum technologies of information security consist of quantum key distribution, quantum secure direct communication, quantum steganography, quantum secret sharing, quantum street cipher, and quantum digital signature EATS. The analysis revealed sufficient numbers of existing PRNG that can be used for various applications. According to the method of obtained PRNG are divided into three fundamentally different classes: tabular, physical, and algorithmic. Also, PRNG can also be divided into crypto-resistant and not crypto-resistant, which in turn include crypto-resistant, not crypto-resistant, and other. The most popular approaches to assessing the randomness of PRNG are the following: NIST, test suite, D-hard test by Georgi Marsaglia, D-hard a random number test suite by Robert Brown, test U01, and KNUF test, and so many others. There are some problem statements. However, all currently developed methods of PRNG are focused on binary sequences, and therefore the development of a method of generating treat PRNG is an urgent scientific task. In addition, assessing the quality of ternary PRNG required the development of appropriate approaches. Therefore, the aim of this work is to develop method, algorithms, and tools for generating and evaluating the quality of ternary PRNG. A method for generating treat PRN is proposed with many vectors and of internal states, a set of keys, of secret keys, multiple initiation vectors, and plurality of source sequences, natural numbers. Based on the proposed method of generating treat PRN, develop an algorithmic treat gen. In the algorithm treat gen, the following parameters are used at this formula in natural numbers. In operation as box, a non-linear replacement of every sixth treat of numbers is performed to the corresponding value of the substitution table. Only one substitution table is used, which is constructed by calculating the inverse element of the field, with subsequent execution of the affine transformation over the field, and is square numbers generate matrix over the field. The final field is fixed by a ring of polynomial which operations modulo and irreducible polynomial. The following matrix values were closed. The construct the proposed substitution table M and vector V. In operation mix square non-degenerate matrix M over the field GF, size 24 and 24, treated multiplex by X above the field. Matrix M built on the basic of array, so that we have in our formula. The proposed method of assessing the quality of parent G, which makes it possible to access of the parameters and patterns of treat parent as well as parent G quality, is implemented in the following states. Step 1, frequency monotreat test. Step 2, frequency treat block test. Step 3, treat run test. Step 4, treat test for the longest run and in a block. Step 5, no overlapping template machine treat test. And stage 6, treat overlapping template machine test. At this slide you can see example of the return of checking the generated sequence of treat gen 1. At this slide you can see statistical pattern of the treat gen 1 sequence. Treat test testing results showed that sequence has passed complex statistical security control. Also, we can specify that transformed binary PRN hasn't passed complex statistical security control by NIST STS. And for conclusion, this paper develops an approach to the generation and evaluation of PRNG as well as PRNG quality, used a comprehensive implementation of generation PRN, different potables, ternary coefficient for the errors function and the incomplete gamma function. This approach makes it possible to generate and fundamentally evaluate the general assessment statistical parameters and patterns of FMT, FTBT, and others. For this treat parent and accordingly to evaluate the cryptographic security of treat parent G and their practical ability for various cryptographic application. And thanks for your attention. Maybe some question when you can ask at the mail. Thanks a lot.